Yo, what's up homies? How you all doing? Today we're going to be converting signed integers into their respective representations in binary using signed bit method. Now you might be wondering, what are signed integers? If you ask me, signed integers are positive and negative integers. The opposite is unsigned integers, which can only be positive integers. So in other words, in a nutshell, signed integers are positive and negative, -5 plus 5. Now with that said, let's begin. For the C code, I believe you will need 4 header files. The math header file and I believe the string header file. We won't really need that for now, but I believe you're gonna need it for the string length function. And for the math header file, it's worth noting that when compiling from the command line using GCC, append -lm at the end. Now the signed bit method stands on the MSB principle. The most significant bit represents the sign of the integer. So the left of the binary representation, you will find 1 or 0. If it's 1, it's negative. If it's 0, it's positive. And out of 2 to the power of n bits for representation, we are able to utilize only 2 to the power of n minus 1 bits. To achieve this, we're going to be using a void function named signed bit that takes the number given to us by the user and the number of bits. First and foremost, we need to check if the number is out of the range that n bits can represent. To do that, we use this simple if statement. Now, if the number is out of the scope or the range, we print number of bits is not sufficient. For example, if the user types 99 and the number of bits is like 2 or 4, so if statements runs. Now for the variables that we're going to be using, it's char, ser, num, and 2 variables I and g for iterations. Now let's check the sign of the number. Now if the number is negative, transform it into a positive number and increment the POS variable. We use POS as an indicator if the num is a negative number. Next up, we use a for loop to transform the decimal number into binary using this for loop. It's quite simple, like this one gave us the remainder and this one gave us the quotient, and the for loop stops if the quotient is 0. Of course, after the for loop is done, I at this stage is holding a value. Now I really faced an issue with this for loop, like when it's running, the string num string stores, I believe, integers and not characters. Now to fix that issue, we use this array as a helper that stores 0 and 1, and this for loop to transform the values into characters, like C char types value. Let's break this for loop down. We have the str num. If it's, for example, y at position 9 and the string num at position 9 is 1, so the 1 goes to the digit 10, and the position of 1 in the digit 10 is 1. So it transforms from int to char. And the string num at position 9 stores 1 as a character. It's worth noting that the string is reversed because of the for loop that transforms the decimal into binary, because we start from below, you know what I'm saying? Now we need to fill the rest of the string with zeros because the number is positive. Signed extension works for positive numbers. To do that, we use a simple for loop with the if statement. Also, the j variable can't modify all the stored values in strnum because thanks to this condition, j is superior or equal I. Now, if the number is negative, the signed extension doesn't work. You know what I'm saying? So we need to add a 1 at the left of the binary number. So to do that, we use strnum n-1 equals character 1. And why are we using like n-1 position and not 0? Cause the string is reversed. Like that's it, simple as that. Now finally, we print the binary value in reverse using a reversed for loop. Let's initiate a new variable called u, and we start from the end position of the array, which is j-1, and we stop if u equals 0. Now we move to the main function. The main function is so simple. We print f, give us a number for the user, and then the user chooses the number of bits, which is n, and we print the value. To compile, we run gcc sign with the name of the C code, then -o for output, then another sign, the name of the output, and -lm because we are using the math string. And then boom, let us run the script. Type a decimal number to represent in n bits format. Let's take, for example, -5, and then choose number of bits n, I believe 16 bits, and then boom, you see that? This is the representation the presentation of -5 using the signed bit method. Now let's take 5 for example, 5, and once again on the 16-bit. Okay, you see that? Wait, let me zoom. For positive it's 0 on the left, and for negative is 1 on the left. Let's choose a big number next. Oh shit. -999 on 32 bits number. Boom, you see that? And I believe that's it. Thank you so much for watching, and I'll catch you in the next one where we're gonna be explaining the first complement and the second complement methods.